I am very pleased to introduce Georgio Nicolas, and he's a PhD student under the supervision of Bart Praneeth and Michael Smart, and he's working at the research group called Leuven, and he has already contributed previously to the PAL, which is one of the symbolic things that I provided, which we have just seen. And welcome, the floor is yours.
This will be a less technical talk than one before, and I'm just going to try to share some of the complaints that I have, my professors, the people I work with have, or my students have when they try to approach using formal methods tools. So yeah, just a bit about me. I'm a second-year PhD student. I've been trying to work with formal methods since 2018. I've worked on some tools that have nice interfaces. Like Noise Explorer is a tool that basically compiles, takes a very simple language, compiles it to a covariant model, and then you can run the covariant verification with it. So that saves you from writing boilerplate. Verifal is a tool that's similar to Proveric, but it's not a formal methods tool. It just does some informal analysis and can already give you some results. Also works in the symbolic model, so we assume that permanence of perfect. But we have some extensions to it that used to work. I'm not sure if they still do. So there's an extension that takes Verifal. Takes Verifal language input, which is a protocol. I wanted to show some demos, but I don't want to risk it with the laptop, so I can show it later. Basically, it takes a very simple protocol description and it reason about it, and can also output boilerplate code for Proveric and hopefully do some further analysis of actual formal methods. I give 2 lectures a year and a course on cryptographic protocols for master students. So I try to introduce why formal methods are useful and try to motivate some students on getting into it. I succeeded with one student who worked with me last year on verifying implementation of Shamir secret sharing and Rust using a tool called Rusty. My love for the computational model is completely reciprocated by the tools. I really like the computational models, but I can't get it to work. And for some reason, everyone in my group thinks I'm the expert at formal methods just because I know a few things, but I'm not an expert. So yeah, I wanted to make something. So cryptography is super cool. It's very powerful. It can let us do amazing things, but it's also fragile. So it's just very, very fragile. Any single flaw and implementation and a proof in any stage from design to binary can basically break the whole system. So we need high assurance by definitions whenever we're deploying the cloud. Instructions and proofs are very complex, and this is perfect material to use formal methods because we can outsource the reasoning and the reproductions of proofs to computers, which kind of behave more predictably than humans in some cases. I wanted to just share a couple of things. I'm also not gonna jump around. So I wanted to show why this is useful. Does everyone have work with cryptography, or do people work with different things like hardware? Okay, so I'm just gonna give a simple example of a protocol that was used in Honda cars. So there's a saw and the cross, and basically there's a symmetric key here. Here, this is programmed out of band, and there's a unlock command. And yeah, basically to unlock the car, the key fob encrypts this unlock command, into a ciphertext. So we let's say this is Leuven. This there's send C here, and then if the car can decrypt the key, the ciphertext with the same key, then it unlocks the car. The same is for turning it on, stuff like that. So if you have any sort of familiarity with crypto protocols, you see that there's an ups. I'm not simplifying the protocol. This is how it works. So basically, anyone who can intercept this message here and replay it can unlock the car again, or turn it on, or basically control the car. There's a proof of concept on GitHub. That's like a few lines of code. You can plug it into this Flipper 0, and yeah, all Honda cars from I think 2014 and like 2006, 2014 that have this protocol are vulnerable. This isn't fixable. This costs probably millions of dollars or hundreds of millions to fix it. But this is just because protocol is not reasoned about or verified at the design stage. So verifying this design stage takes some researchers look at the protocol. No reason about it could cost some money, but in the long term could save a lot of money for these companies. Also could save people from getting their cars stolen. Anyway, so I will complain a bit about some of the issues that we face when we try to do this for reasoning. But whatever I say does not discredit any of the amazing work that's been done by the community. I love everything that's been done. We couldn't have been having this meeting if it weren't for people contributing to the proposals and maintaining them for years and years. So we have a plethora of tools that do symbolic verification, that have secure compilation chains. We have stuff that works in the computational model for cryptography. But I still think we can do better in some aspects. So these are the main concerns I'm going to discuss in this talk. So we're about resolving dependencies, both humans and software, status of teaching material and documentation that's available, ability to reproduce and reason about results that other people have obtained or published, and the general friction when anyone has a result and tries to get it accepted or peer reviewed by the community. So, okay, here we go. So our tools normally have a dependency chain. Like you have to install whatever open stuff, and then this can be painful because you need the right version and you need to get everything in order so that it works. But we also have human dependency chains, which is quite hard to like put down on a paper, and this is something I've noticed that hasn't been quite discussed. And mainly because I come from a background where I learned all of this stuff on my own, so I didn't go to like a class where someone taught me about formal methods. I was just super curious. I put my head into it. I tried. I failed a lot. So this is what a dependency chain for EasyCrypt looks like. That's the main version. But then on the human dependency chain, what I mean by this is that you need to know about cryptography and some formal definitions. You need to know about game-based proofs. You need to know about distributions of probabilistic logic. You need to know about type functional programming. It goes on and on and on. And so listing these things, like let's say I have a scheme. There's a super motivated PhD student. I want to work on this. Okay, I have to learn these things. Okay, fine. I will spend a month or two and learn all these things. But how can I be sure before I start that this is everything that I need to fix the scheme? There is like no way for me to know if like the months I'm gonna spend working, for example, on zero knowledge proof, like trying to figure out how to get easy working, thinking of how to model things, and then I found out in the end that there's a property called rewinding. It's basically impossible to do in EasyCrypt, or maybe I couldn't find someone who knows how to do it. So it's kind of unnerving and frustrating for people who are kind of taking risks, and like your promoter wouldn't be happy, and these things happen. So it's quite hard for people who cannot afford to take risks on such projects to plan, okay, if I want to do this, where do I start? And this is more critical when there's no access to an expert in the research group, and experts do not exist in research groups. I think my group is quite well funded and they do some really cool stuff, but I'm the only one who's interested in formal methods for some reason. So unless I go and bother people to ask them, okay, how do I do this? And then they have to find like an hour to talk to me with their very busy schedules, there's not really a way for me to progress in some tools. Again, I'm not blaming the developers because, yeah, everyone has a lot on their plates, but this is just the problem that exists. Okay, about the other side. So what I thought, okay, what if there's good teaching material to do this? Because I saw the communities of Lean and general mathematics community, they have excellent teaching material for generic use of proof assistance. So like you want to formalize, I don't know, any theorem in math, okay, you can understand the theorem, you figure out how to use the tool, done, you can do it. Sometimes it's hard, like you have to do the stuff of trying to get the computer to understand it, like exactly what you want to put in the proof, but it's feels like this friction is much higher when you try to do any sort of reasoning with crypto primitives and the computational model specific. So I will not name tools, and I don't want to say like these people are doing bad at documentation. Some tools do much better than others, and I've asked some people like, why do you not have documentation for this? And they said it doesn't write its papers, and then we're basically like wasting time if we want to write documentation. If you don't have a question, come ask us. We're happy to help you, but it doesn't really like this is one of the best result producing tools the communities. Someone said, like one of the maintainers of it. So I think that if we get some, like we manage to convince a few people, even the students who learn about this tool by writing some documentation, we might enable a lot of other people to use this tool without bothering that maintainer and having that maintainer just focus on developing the tool itself rather than answering questions or using the tool for some results. So I have no clue how we can get better at that. We're a bunch of experts here, so I would like to hear some thoughts or, I don't know, some ideas on where we can start. And about reproducing and reasoning about results. So in some cases, like a proof script can be about like, I don't know, 1,300 lines for basically your secret sharing in one paper. And this paper used the tool, a specific version, like they use a specific commit of a tool that uses, like the commit was squashed, so it's gone now. It's impossible to reproduce whatever's, like they published the code of the proof, it should work, but it's impossible for us to reproduce it. So it feels like if I were the person who wrote this, I would feel bad because my results have lost a lot of value. But it's still an accepted paper, so it's okay. Someone has checked this probably. In some cases, also it's quite hard to install the tools that we need to reproduce the results of someone else, because a big part of format is its ability to reproduce other people's results quickly, rather than having to go through a written proof and go through the steps. So I don't think a reviewer will spend 4 hours on installing a tool, and if it works in the end, just to try to reproduce the result, if the tool is quick. So that's for our setup, not for any. And yeah, and in some cases, it's impossible to, yeah, I mentioned this before about the version of the tool that no longer exists, or the dependencies don't exist. Or the language itself that was used in the script is completely incompatible with current versions. You have to figure out which version might have it working. So last thing is about academic frictions. So I've tried submitting a few very small and humble results, but then we get responses like, okay, you've used the tool, that's not enough for a paper. Okay, but if people who are learning are always like getting sticks in their wheels when they try to get a small result and be happy about it, how can we motivate these people to keep going rather than just like, can we find a way that's different from publishing academic papers for junior researchers that can let them publish the results so that they can be get some sort of credibility in the community and start working more, like, because yeah, this is a problem I've seen. That's not just from me, it's from other students, professors also think like this. I will not name people. Yeah, some non-reproducible or flawed proofs just fly under the radar. And in some cases, like recently, work happens on behind closed doors on some protocols like Apple's TQ3. The proof was published, like the analysis was published by the time the protocol was announced. So this goes against the principle of having community look at the protocol, same way that we did for TLS, which is excellent. So yeah, in conclusion, tools we have are great. For those who are good at them, it's excellent. We wish we can have more people to be great at these tools so that the community can thrive and have better results and good software and services we use. The problem isn't really with the tooling. So how do you think we can get there? So I just want to see if the rest of the time I have, if anyone has any thoughts that they would like to share. Yeah, that's it.
Yes, so I have a few thoughts that I would like to share. So I am one of the two former method guys in my group, which is like systems engineering. So in principle, I share a lot of your feelings that you shared. So talking to engineers and having a feel of what exactly is going on. Okay, so they will tell you buzzwords like Kubernetes and this and that, like this and that. Okay, so tell me what exactly is happening inside this, how the keys are transferred from this to this, how this is going from this to this. So that's really a challenge, and I completely agree with you on many of your points. Also, I think the credibility point, I really like that. From that perspective is my question or a comment. So what do you think, how can Europroofnet, for example, give this kind of credibility that you were asking for junior researchers or kind of initiators? So can we provide them a platform? Do you think, like, how would it proceed? What would be the required mechanisms? What do you suggest as the first starting point? For example, let's say the working group 3 is going to provide such kind of platform. And I have another comment, but that is somehow related to IRDF, UFMRG. I think is a very good platform for that.
What is it?
So
Yeah.
in IRDF, there is usable formal methods for this research group.
Okay, yeah.
So that research group is actually targeting the same thing, which is reusability. But for the last year, they unfortunately haven't targeted the usability. They are just giving tutorials and so on. So not improving the documentation, which is really something that I try to push them towards, or is really a requirement. And I have the same feeling for like many of the tools that I work with. But I would like to know your thoughts. So if we provide in Europroofnet this kind of platform, what do you think would be the first step to go to?
I'm not the expert, but I would be inspired by what.
Starting ideas.
But what? Sorry, yeah, I would be inspired by what the Lean community is doing with their coverage of like when they were porting, I don't know if people are familiar with it, when Gene4 came out, there was this big community maintained library of proofs about general mathematics that was written in Gene3. And then the whole community worked to move this over, I don't know, 2 years maybe, from Gene3 to Gene4. So this got a lot of people who learn about how this tool works. They wrote documentation along the way. I think it's a very usable tool. I think we can do something similar, like have a repository of our results somewhere, I guess. I don't know how feasible this is. It is technically feasible. You do things that are much more complicated than this. If that's something that's interesting, I think that's a good idea.
Yeah, I think that's a good idea. And we have some discussion with the end session that how we can kind of.
So there are people in Europroofnet and other working groups that I've met, like the people who work with the duct team, the people, there's a bunch of people collecting a database of proofs. So there are people in Europroofnet working on similar stuff, but not with cryptography. So I don't know if there's enough people who are interested in doing this. This is something we can do for sure.
Yeah, related to on your talk, I had the impression that you basically mostly focus on proof, on cryptographic proof like easy share, easy crypt, sorry. So for those tools, yeah, the learning curve is quite steep.
Yes,
because the model, I really agree with the idea is behind. So if you start with this as an autodidact and without formal background, it's I can understand that it's quite steep. Which is why I think the identifying if you work on a protocol, for example, that one you don't need the crypt to realize that
exactly.
Yeah, from the tool. But so yeah, I think it will take time no matter to get good at any tool. There's tools that are definitely have less of a steep curve. If you take, for example, tools that are less powerful, the one that works on bounding obsession that are more restrictive, those are more like really push and buttons. You don't need to do much. But you also do less things, but still it allows you to learn the same kind of knowledge. If you start directly with the complicated one, so yeah, that's the document collection stuff. I completely agree with you. That's done. Theoretical aspect of it, unfortunately, it's kind of mandatory.
I started with Proverb at the very start, so I think if I started immediately with easy crypt, I would have given up. But Proverb, when the time I started it, it was a bit, no, it was significantly slower than it was in 2018. Now it's much faster. So, and the course I teach, I started showing them just to show them like how we can model something, and then at the end of the lecture I started introducing how we can prepare, and I found that I wouldn't like introduce unbounded sessions or stuff like that. I just show how we can model something, what is a query, these very basic things, but that's something I had to come up with on my own, and I had no experts, so maybe I'm doing it like checking what I'm doing, so maybe I'm doing it the wrong way. But I agree with you, we should at least like find build a ladder that we can show someone, okay, you start here, do this, you'll get there eventually. But if you start from scratch and you think on the roots, I agree with completely, it's very good.
Yeah, just an observation. What I noticed, I used to be a formal methods person before, I became the same. You go to formal methods conferences. I was involved in the building of one formula. I won't mention the name. The people building the tools never use them. If you really want to go to a formal methods conference as an industrial person, and say, hey, we used your method with this tool. and this is our results. And you will invariably be told, A, use the method wrong, B, this is informed methods, C, use our tools wrong, and you industrial people don't know what you're talking about.
Yes.
What a great start. So some of the things we talk about here, I mean, it all comes down to the fact that we've got one community of people who are producing tools for themselves. And that's a common thing that happens everywhere. But as soon as it's employed in a different domain, you're doing it wrong. And then you just alienate people. It's frustrating.
It's quite unfortunate.
I'm with you.
Yeah, so the lack of documentation, so that's critical, right? And it's not the kind of job that most people find fun. So they will not spend their own time doing that. You typically need to pay to do that and to do the job. And probably something that you might want. So back to what Ian says, create more a stronger relationship with the industry, because they are the guys that will probably put the money on the table to actually fund this kind of thing, which is critical. Right? So you need to convince industrial partners that your work is super relevant to them. And that's
In some cases, this happens.
Yes, exactly.
Big companies working on tools when they need them. It happens. And also, like the thing that came up with the White House is kind of nice. So I think we can use that to motivate people in the industry to spend
But
more.
instead of doing that on basis, you need to have that relationship established and continuously established so that you can, create this kind of
Yeah, I think,
stable institution that maintain the.
yeah, maybe this is something we can do. We have experts and people who are very well connected. That's a good thing.
Yeah, so I have a few observations. As another cryptographer that actually hasn't done any formal methods background, I find the idea really appealing because proving things in classical cryptography is an absolute pain, and no one knows how to teach you how to prove things. But I wonder why. I haven't really managed to make headways there, but I don't know why people in the cryptography field aren't looking for better tools when they exist. Obviously, maybe they're not, as you say, they're too hard, but there's a problem with the status quo, even if you ignore the normal, the formal methods field as it is just now. And so yeah, that's a thought. The other thing I wanted to say was I'm really inspired by some people in biology, I think especially, are kind of doing a lot of work in this idea of like micro publishing, where it's basically like just whenever you run an experiment, you kind of have a platform that's like almost like tweet size and say, this is experiment to run, this is the result. And then you kind of get, you can get credit for that even if it doesn't turn out into paper, because you already pushed a little bit further. And there's another idea from that field that is also kind of interesting, where like there's venues where you can pre-commit your intention. So you can say, I want to write a script that proves this thing before you've actually written it. And then it's kind of like, it kind of gives you this option about like, you produce a result, and then, if it doesn't work out, that's also like a learning tool for the next generation. I tried to prove this probable in this formal method thing. It didn't work. Why?
Yes.
And that's a useful tool for students. And it gets published anyway, because your acceptance relies on what you want to prove rather than what you have proven. So I think to some extent we need to play a little bit with those alternative formats of publication.
Yes.
And then final point, I'm not sure if I lost this, but within your presentation, did you think what was the relation between formal methods, tools like Provide versus things that are formal, verifiable implementations? And is that maybe a more interesting target for some people?
For me, this is the most interesting, honestly, because the reason why is because I'm already good at implementing and I know how things work in general. Like I think a lot of people feel the same way. Like my master's student, I think, because we discussed doing multiple things, wanted to work with secret training. And this was the thing that we found, okay, we can get a result here. So the tools for implementing, proving things about implementations are kind of more accessible because you're starting with a language that you may be familiar with or that has tutorials that you can learn in 2 weeks or 3 weeks. Then you can start verifying the properties about the program. Yeah, so the thing about micro-publishing is super interesting, but yeah, again, I don't know if I can achieve that. And material like the tutorial you had today is really like it's something that it took like the stuff that you explained takes so much maturity with it and experience that for me it took me multiple years to get to think about the things and present them in a way close to what you were doing. So if this presentation can be shared, it's super valuable. Yeah, so this is things like that. Even if we start with presentation and 2-hour talks, that's already fantastic. If the tools stay similar. We don't change the syntax, which for programmers.
I think so. There's two comment on this. So for the tools, even on implementation, the proof of implementation, the problem that's I think one of the problems that the verification, if you want to do the problem itself of verification is really hard. But one of the reasons why EasyCrypt or CryptoVerif or the other or F-star or something like this, where it's super hard to use. The problem they're trying to solve is inherently very hard to reason, even if you want to do the proof by hand. Yes. With the tool that you have to guide them, they have their own system, and but which also why I'm surprised that you're saying that you can't manage to get published if you just use it, because if you do a case study and like your case study, you put in the protocol, all that relevance, you show it works using the tool. I mean, I have a lot of publications that are basically just this. So that's why
maybe we're selecting the wrong values. Maybe
it could be, yeah, it could be the news, or it could be also, it can also be
the result of the
review process is kind of very random sometimes, where you get the reviewer that is not out in the domain, like, okay, let's sometimes you get exactly an expert and you're like, okay, cool, at least you understand my result. But case study, you can get into like a top rank conference. Must be, if it's a very small protocol like this, probably it's not gonna give it a phone and then start it. Usually get published.
Yeah, we've been working on Matter, the thing for IoT.
Yeah, so I mean, this is usually I think both the developers, at least personally, my personal thing as a developer, both case studies, I like to see a case study published because it's also I have my own way of modeling, but some people use the tool in a different way, and sometimes it's kind of, oh, that was a cute idea. Yeah. And you can, so if it's only 5 people always using the same tool, then you get into
yes. Okay. Yeah, I think we will every time, but thank you very much.